In an earlier video, we looked at the place value and face value of numbers of a number in base 10, right? So that was an example of a base 10 number, and we saw that the face value of each digit is just the digit itself, but the place value is the digit times or multiplied by the value of the place in which it was in that number. All right, what we want to do now is look at an example of the face value and place value of a base 2 number. An example, for example, suppose we have, say, 11010101. All right, so we want to look at the face value of each digit here. And remember, by the way, that each of this is called a bit, right? Which is shortened form of binary digit. And then you put more than one bit together and you get a byte. And you remember, when you put more than one of these, this is a byte, contain more than one bit, and when you put more than one byte, more than one of these together, you get a word. All right, it's called a word. But anyway, where are we now? We're looking at the face value of each digit. Now, the face value of this digit is 1. The face value of this digit is 0. Of this digit, 1. Face value of this digit is 0. The face value of this digit is 1. The face value of this digit is 1. The face value of this digit is 1. Good. Now, what about what is called the place? Let me write that a little better. The place value. All right, the place value. Now let us make a little table. Oh, by the way, I changed my mind about the table. We've been looking at it using tables, but I'm sure we can manage by now looking at these values without the table. Now, this, if you were to use a table, this, just like how in base 10, the number to the right would represent how many ones, then the next number to the left of that would represent how many tens, then the next one to the left how many hundreds, and so on and so forth. This represents how many ones. Let me make it a bit thicker. This represents how many ones, but this now, this 0 represents how many? It's not tens, it is twos. Then this one is representing how many fours and eights. Notice it's doubling each time because this is 2 to the power of 0. 2 to the 0 gives you 1. 2 to the power of 1 gives you 2. 2 to the power of 2 gives you 4. 2 to the power of 3 gives you 8, and so on. 2 to the power of 4 gives you 16. So actually these numbers are doubling. So 16 2 is 32, 64. Good. So now, looking at place value, this is 1 1. All right, so this is just 1 1, but this 0 is 0 twos, so it's 0 by 2, which is just 2. This is 1 by 1, which is just 1. Now what about this 1 here? The place value of it is 1 fours, is 1 by 4, which is 4. The place value of this 0 is 0 eighths, which is just 8. The place value of this 16, this is 1 16th, which is 16, and 32 and 64. But you get the idea, right? So this is 132, this is 164. So these are the, what did I do here? Let me go back here. 0 times 8 is 0. 0 times 2 is 0. Right. This is 0 twos. This is 0 8. Alright, so here this is 1 1. That's a place value. When you place this in the second position to the rightmost, it has a value of the digit times 2, so it's 0 twos, which is just 0. The next one, the third row from the right, it represents fours, how many fours you have. So this is 1 fours. This is representing how many eights you have. This is 0 eights. So the place value is really 0. This one, the fifth from the right, is telling you how many 16s that you have. So it is 116, right? So even though it's a binary number, I'm writing the base 10 equivalent here. This is 1/16, right? This is 132 and this is 164, the place value. All right. Okay, so we're going to look at face and place value of a base 4 number next. Let's keep that to a different video.